Hi, my name is Haris Jalani, and this is my Lab 1 video report. The objective of this lab was to analyze the motion and position change of an object moving at a constant velocity, which relates to Newton's first law of inertia. I did this by rolling a basketball across the floor of my room and recording it with an iPhone camera, and then putting the information into the tracker motion capture software, as well as predicting this motion with the GlowScript software. A brief summary of these results is that the ball moved at a seemingly constant motion of about 0.9 meters per second over the recorded period, which indicates no net force. There was some slight deviations between the predicted and the recorded times, which can be attributed to some small forces acting upon the ball and human error in the motion analysis. Here you can see the motion analysis on the tracker app. A basketball has a diameter of about 24 centimeters, so I set the measuring stick as 0.240 meters. The red dots represent the center of mass of the ball as it moves across the floor, and to the right you can see the position versus time graph as both a graph and in a table. So, as you can see, the graph is a straight positive line with a slope of about 0.9, which means that the ball was moving at about 0.9 meters per second. There are some slight discrepancies, but the line is overall almost entirely straight. These discrepancies can likely be attributed to human error, as when I plotted the center of mass of the ball, it could potentially have been off by a small amount. Or it could be represented by maybe the fact that the ball isn't a perfect circle or other factors outside of my control. However, as we can see, the line is almost completely straight and can be seen as a good representation of the velocity of the ball. So if the axes were flipped, then the line would still be very similar, but instead of being positive, it would be negative, because from the point of view of the tracker app, if the axis had the positive and negative x values interchanged, the ball would be moving at the same speed, but in the opposite direction, leading to it having a negative velocity of the same magnitude. Here you can see on the GlowScript app my predicted position versus time graph. So since the average velocity was about 0.9 meters per second, we would predict the position versus time graph to be a straight line with a slope of 0.9, which is what's represented here on GlowScript. And finally, here's an Excel page which has both data points graphed against each other. To the left, you can see the raw data, and to the right, you can see the two lines graphed on the same graph. So you can see there are some very slight deviations with the tracker position versus the GlowScript position. They both have a very similar slope, but the tracker values are slightly less than the GlowScript value. Again, this can likely be attributed to human error, and we can see that the actual velocity of each ball is still more or less the same. The lines have almost the exact same slope. As you can see, the ball moves in a straight line at a constant velocity across the floor of my room. This is because there are no major net forces acting upon the ball, so this means there is not a change in velocity. As you can see, there are a few relevant formulas on the screen right now. The final velocity is equal to the initial velocity plus the net force divided by the mass multiplied by the time elapsed over the duration of the recorded period. So, since there is no change in velocity, we can see that F net must be 0, because Vf is equal to Vi. Force is equal to mass times acceleration, and acceleration is a way to represent the change in velocity. Thus, if there was a change in velocity, that means that there is some acceleration, and that's indicative of a force being applied to the object. However, since there was no acceleration, we can also see there's no force. Newton's first law states that an object in motion will stay in constant motion and an object at rest will stay at rest unless an outside force acts upon it. This is known as inertia. Through Newton's first law, we can see that because this object stays in constant motion, there is no force acting upon it. Finally, we can also represent this with momentum. Final momentum is equal to initial momentum plus the net force times the time elapsed. And momentum is mass multiplied by velocity. Thus, any change in velocity will lead to a change in momentum. However, because there's no change in velocity, momentum is constant throughout this period. It should be noted that unless you're in a vacuum, there's no way to fully prevent any forces from acting upon an object. So for example, in this case, although there were no major forces causing any large changes in velocity, there were definitely forces such as friction from the carpet, air resistance, or even other forces that we are not even aware of that caused the velocity of the ball to change. However, since the recorded position versus time graph on tracker was relatively similar to the predicted position versus time graph, we can assume that these are not significant towards the velocity of the ball. While it is impossible to count which specific pushes and pulls and how many forces total are acting upon the ball, we can see their magnitude because the total net force is 0. Thus, however many pushes and pulls they all cancel out. Overall, this lab is a good representation of Newton's first law, showing how inertia works, how an object in constant motion will stay in motion, and how changes in velocity indicate net force.